one of the things that we need to be able to do is we want to be able to draw chair conformations. And there's a couple ways of doing this. For those of you who want some steps, this is one method. So the first thing to do with this method, let me just zoom in a little bit here, is to start off by drawing parallel lines. So we're going to draw two parallel lines. So we'll draw a parallel line going down this direction, or we'll draw a parallel line with them coming up like that. And we want to get them a little bit off. So notice that this is about right here, and that goes to about right there, right? So they're not perfectly on top of each other like that. And then what we're going to do after that is from the ends, we're going to make a point either pointing up or pointing down. So if we're going down here, then we want a point that's coming up like this, right? And if we're going up, we want to bend. So we want to come down like that. So that's going to be, right, that's like one part of your headrest here, and this position, and then this would be like your leg position of the other chair, right? And then on the other end, so if you went up here, then you're going to come down here, and then you connect those points. And if you're looking at chair conformation number 2, you would come up to this position here, and then connect those just like so right here, right? So again, you make a point up here, and you connect. Make a point down here, you connect those, right? Or you connect to a point here, or you connect to a point up there, right? And then when you're done with that, you go through and you don't use dotted lines. You finish them up by putting in the solid line there. Now, once we're done with that, we need to be able to put in our H's, or whatever atoms there are at those positions. So what I like to do is I start off here and I come up, and let's just make that an H right now. So remember, we kind of said that once we have this position determined, we kind of know where all of the other H's are. So up, down, those are axial. We come over here, that's up, another axial, that's down, this is up, and then that is down. So literally when you make this thing and you give it a little bend, you have these three little kind of legs that the cyclohexane sits on. Right? It would sit on a flat surface from there. Now over at this other one, that's pointing down. So remember, we want it to look like a tetrahedral, so we're coming down first. And then we're coming over here, come up, right? And then we alternate as we go around the ring here to get all of our axial H's in position. All right, now putting the equatorial H's in is a little bit trickier. Remember, we want the main goal here is to have these look like tetrahedral. So we want this to come down just like so. And really we want that bond to be about parallel with the carbon bond that lies behind it. So about parallel with that. That's our goal. Here, that's going to come up. And we want that to be about parallel with this line. Okay, so there's your other H. Notice also that if we were to look down this bond here, that would kind of fall between these two. So it should look like it's staggered there. So coming around to this position right here, we want to put in our H. That H needs to be about parallel with this line, and they're all pointing out. So there's another H. These are all the equatorial positions. Now we're coming around right here to that position. That's going to put an H right there for us. And then here we're coming down basically parallel with that. And this last position right here, we're going this direction, right? Which means our H should be pointed out just like that. So that's going to be a really good chair drawing. Okay, so nice equatorial and axial positions there. And then we would carry out the same kind of task over here for the other structure. So going through, we need to put an H right here. Right, we want that H to be roughly parallel with the carbon-carbon bond that lies one carbon behind us. Coming over here, should be roughly parallel with that carbon-carbon bond. Right, moving over here, that's going to come up roughly parallel with this bond right here. Right, at this position, that needs to be about parallel with this carbon-carbon bond. Right, so we're talking about this one right here. So that H needs to come down to right there. Right, now we're coming over to this position. And so that position right here is where this H needs to point. Right there. And then the last one is over here. So that's coming down. So because we're going that direction, this needs to be pointed down here also. All right, so you want to practice this. And if you draw this out on a piece of paper, I don't know, half a dozen times each, you'll get a hang of it. Now we need to be able to do this because we want to understand how to do this chair-chair interconversion. And remember that that carbon number 1, right, just numbering this thing arbitrarily, those carbons don't really move the relative positions. We just change kind of how we bend the molecule. So that's your carbon 1, that's 2, 3, 4, 5, and 6 here. Okay? Now, again, our main goal here is to get to the point where we can do a chair-chair interconversion. So if we look down here below, that's kind of the idea behind this. This is what we just did up above, right? Noticing here that we have our axial positions. So these are all axial right now, right? And these are equatorial. And then notice this. This is an interesting pattern. It holds true for all of these chair-chair interconversions. Is this axial position, when that number 1 gets pushed down to this position, right? So in other words, when that 1 right here comes down to this position, this axial becomes equatorial. So that becomes equatorial. Notice also that this equatorial here is this atom here. So that becomes axial. So as we do this, all of our axials become equatorial, and all of our equatorial become axial. And as we're going to see looking at some Newman projections, these axial positions are more sterically hindered than the equatorial positions. So in the end, what we're going to have to do is we're going to be given a structure, a compound like, let's say, toluene, and we'll be asked to draw the most stable chair conformation. And we're going to have to make a decision, is it chair number 1 or is it chair number 2?